So you'll notice on the homework that you'll be given a whole list of series, and then you're going to be asked to figure out which test to use and then apply that test to determine if the series converges or diverges. So let's take a look at our flow chart. So our first step on the flow chart is, do we have a recognizable form, a geometric series or a p-series? If not, we want to apply the divergence test. To do that, we're going to take the limit as n goes to infinity. If it's not equal to 0, then we're done, our series diverges. However, most of the time it will be equal to 0, and so the next step is to decide, do I have positive terms or alternating terms? For positive terms, we've already learned the integral test and the direct comparison test, and now we're going to add the limit comparison test. So this will be your go-to test if your series looks like a polynomial over a polynomial. It's also, if DCT doesn't work, if you can't get the inequalities to line up in a helpful way, then you would want to try the limit comparison test next. So I'll show you a trick for the limit comparison test. It should make it quite a bit easier. And when I was a Calc 2 student, I liked that trick so well that I ended up using the limit comparison test much more often than the direct comparison test, because it just meant I didn't have to think so hard. So it's a really nice trick, and we'll take a look at that. So let's see what our limit comparison test is. Zoom in here. All right, so you'll be given a series, and you're going to call that a sub n. And then what you need to do is choose a b sub n. And my strategy for b sub n is to pick the term with the biggest power in the numerator and put it over the term with the biggest power in the denominator, right? And then you're going to take the limit as n goes to infinity of a sub n over b sub n. So you are dividing fractions here. So when you divide fractions, you want to multiply by the reciprocal, or some people call that like same dot flip, or some other cute acronym or sentence for remembering that. But ultimately it means that this is the limit as n goes to infinity of a sub n times 1 over b sub n. Okay. All right, so once you've taken that limit, now we need to look at this criteria to see how we figure out if our original series converges or diverges. So you need L to be between 0 and infinity, and you need the series of b sub n to converge. If you have both of those, then your original series a sub n converges also. And similarly for divergence, if L is between 0 and infinity, and the series of b sub n diverges, then your series of a sub n will also diverge. Okay? So either they both converge or they both diverge. So I think of this as like a three-legged race. So either both of you are still running in the three-legged race, or both of you are on the ground. It doesn't really work if one person is trying to walk and the other person's on the ground getting dragged. That doesn't, that's not very fun. So I always think of this as both converge or both diverge. Okay, and mathematically speaking, we can look at this as kind of being a sub n over b sub n is roughly equal to L. So that means that a sub n is roughly equal to L times b sub n. So if a sub n converges, that means that b sub n times some sort of constant is going to be equivalent to a sub n. And similarly, if a sub n diverges and L times b sub n is roughly equivalent to that, that means b sub n also diverges. Okay, so that gives you a little bit of a more math, slight proof. There's a little more involved to that proof, but it helps give you an idea of why this works. So let's try this out on number 1. I have the series n equals 2 to infinity of n squared over the quantity n to the 4th minus n minus 1. So my a sub n is n squared over n to the 4th minus n minus 1. So I'm not writing any of these with a series. I'm just writing out the formula. My b sub n, I'll pick the biggest power in the numerator. There's only one thing, so that's just my n squared. And the biggest power in the denominator is this n to the 4th. All right, so I have an a sub n and a b sub n, so I'm ready to find my limit. So L will be equal to the limit as n goes to infinity of n squared over n to the 4th minus n minus 1 times, I have another fraction here, so I'll put the n squared in the denominator, the n to the 4th in the numerator. And let's simplify this limit down a little bit. So this is the limit as n goes to infinity. So for this piece of the limit, I have n squared over n to the 4th are my leading terms. And that'll be times n to the 4th over n squared. Okay, so these will all cancel out, and this gives me a limit equal to 1. So my write-up here is going to be, since L is equal to 1, which is between 0 and infinity, And, all right, so I need to make a statement about my B sub n. So let me come back over here and simplify that. N squared over n to the fourth is going to be 1 over n squared. So since L is equal to 1 between 0 and infinity, and the series from n equals 2 to infinity of 1 over n squared, that's a P series. P is equal to 2, which is greater than 1, so it converges. Therefore, my original series, n equals 2 to infinity of n squared over n to the fourth minus n minus 1 converges by LCT. All right, so that is my write-up for that one. And then let's go ahead and look at number 2. Okay, and I would like you to actually pause the video and give this one a try. All right, so there are 2 choices that you could have made for this one. Let me zoom back in here. Let's look at the first choice. I think there's 2 obvious choices. There are other choices you can make, but there are 2 choices that I think are pretty obvious. So the first one I'm thinking of is that B sub n is going to be, my biggest term is that 3n cubed over my 5n to the fourth. So the 3n cubed over 5n to the fourth. So L is going to be equal to the limit as n goes to infinity of 3n cubed plus n minus 7 over 5n to the fourth minus 7 times, I'll put a 3n cubed in the denominator and a 5n to the fourth in the numerator. Get my leading terms here are all going to cancel, and my limit is equal to 1. All right, and then now let me simplify my B sub n. So I'll pull that 3/5 out in front, and then I have an n cubed over n to the fourth, so that gives me times 1 over n. All right, so my write-up is, since L equals 1, which is between 0 and infinity, and I have 3/5 times the sum from n equals 2 to infinity of 1 over n. Okay, that is a P series. P is equal to 1, which is less than or equal to 1, so it diverges. Okay, also, this is the harmonic series. 1 over n is the harmonic series, so it's also okay if you recognize that to just write divergent HS for harmonic series. So that's a totally acceptable way to justify that as well. So therefore, my original series, n equals 2 to infinity, of 3n cubed plus n minus 7 over 5n to the fourth minus 7 diverges by LCT. Okay, so there's my write-up. And then I want to do one other thing with this problem. I want to look at a slightly different choice for my B sub n. So instead, if I pick my B sub n, I'm still going to look at these leading terms, but maybe I'm going to leave off these coefficients. And I want to show you how that changes the value of the limit and why I usually include those coefficients. And you're certainly welcome to do it as long as you're, any way you want, as long as you're meeting the requirements of the test. So another choice for B sub n could be that you chose the n cubed over the n to the fourth. Okay, in that case, my limit now is going to be L is the limit as n goes to infinity of 3n cubed plus n minus 7 over 5n to the fourth minus 7, and that'll be times. I have an n cubed in the denominator and an n to the fourth in the numerator. Then let me simplify this. This is the limit as n goes to infinity, so I'll take my leading terms in this first piece. 3n cubed over n to the fourth times my second piece here, n to the fourth over n cubed. Oops, I forgot my 5 there. All right, so my n cubes will cancel, my n to the fourth will cancel, and that leaves me with 3/5. So my L is equal to 3/5 here, which is still between 0 and infinity. So I'll still get that this is going to diverge. So the conclusion doesn't change, but it is a little more work to find your limit. So this is why I usually include these coefficients, because then my limit comes out to be 1 almost all of the time. All right, so I hope that helps, and we'll see you back for problem 3.